Okay, so last we left off, we were talking about organic chemistry. We had just started talking about the different uh, prefixes and the suffixes. We've talked about alkenes, alkanes, and alkynes. And now we need to talk about what happens when you start having mixtures of both. Okay. So we also talked about how to look at the skeletal structures. Okay, so a quick recap. So when we talk about skeletal structures, each point represents a carbon. And that carbon, if it's a single bond, will be saturated with hydrogen. Carbon can have four bonds. So for instance, this carbon here would have one carbon and three hydrogens around it. This carbon here would have one carbon with two hydrogens around it. And then attached to both of the carbons. So remember, saturated basically refers to the bonds, the hydrogens that are surrounding it, and that everything is a single bond. There are no double bonds. So again, this is going to represent that first carbon. This is going to represent the second carbon. This is going to represent the third carbon, the fourth carbon, and this is the fifth carbon. 1, 2, 3, 4, 5. And hydrogens on this one. So in the case of a double bond, double bonds are considered to be unsaturated because they're not saturated with hydrogens. So it's considered to be, this guy is an belongs to the alkane. Okay, so this is a 4-carbon chain. We have a double bond between the first and the second carbon. This guy, since it has one double bond, it's going to be an alkene, belong to the alkene group. So what this looks like, so it's going to be a double bond between the two carbons, because we know that hydrogen can't form double bonds, and hydrogens can't be in the center, a center atom. Okay, so those are the 4 carbons. And you'll see the first carbon has a double bond between between the first and the second carbon. Now, you'll notice there's 2 hydrogens here, not the 3 that we normally have, because we have to have a total of 4 attachments or 4 bonds. So that's 1, that's 2, and a double bond counts as 2 bonds. Okay, so that's a total of 4 around it. And the center atom, this second carbon, it has those 2 from the double bond, 3, 4. So carbon is always going to try to have 4 attachments, okay, or 4 bonds around it. Hi, Vernice, how are you? Can you hear me? Vernice, can you hear me? Hello? Hello, can you hear me? Let's see. Hello? Oh, so yeah, you can hear me? That's good. Can you hear me better now than before? Okay, good. I apologize for the music in the background. I had to go to a Panera because of driving in today. The fog was so bad that traffic was so backed up. So hanging out in a Panera teaching chemistry, best thing to do. Okay, so if we looked at the triple bond, okay. So in this case, we have a triple bond on the first carbon. So this is also considered to be unsaturated because you don't have 4 individual bonds surrounding it, the carbon. Okay, so this is that first carbon, this is the second carbon, this is the third carbon, and this is the fourth carbon. So this 1, 2, 3, 4. And this is an alkyne. Bernice, do you know at Harnell, do you guys get Thanksgiving week off? Or do you guys go to school the first 2 days or the first 3 days and then have to look at the schedule? Because I don't know if you guys get it completely off. I need to find that out. So anyway, this is also considered to be an unsaturated hydrocarbon because, again, it had that triple bond. So if you have a double bond or triple bond, it's considered to be unsaturated. If it's all single bonds, like here, then it's saturated. Okay, now when we start nomenclature, if you guys remember, we have the prefixes. So if we had 1, it was meth. 2, meth. 3, 4 Ute, 5 Penta. 6 Hex, 7 Hept, 8 Oct, 9 Known, 10 Deck, 11 Undeck, 'Okay, so we will have class on that Tuesday then. So then I'll see you guys on that Tuesday. Thank you. 12 is Dodeck. And I'm just curious, because I can see the writing. Can you see the writing, my prefixes showing up on the side as I type them? Okay. Okay, so those are your prefixes. So when we're starting to do our nomenclature, like we did last week, we count the longest carbon chain, and that's going to be the base. That's going to be the N, or like I like to say, the last name, right? So we have the prefixes, and then we use the ANE if they're all single bonds. So in this case, we have 5 carbons. 1, 2, 3, 4, 5. So this guy would be, since it's 5 carbons, we'd call it pentane. This guy, it has 4 carbons. It's a 4 carbon chain. 1, 2, 3, 4. We call this butane. So since there's a double bond, we have to put E in E, letting us know that there's a double bond there. And this guy, since there's also 4 carbons, we'd call this guy butyne. And this is IUPAC nomenclature. There's also a common name nomenclature, which I won't talk about. You'll probably get more of that if you guys take the like the intro to organic chemistry. They'll go in a lot more detail. But I want to teach you guys some of the basics of IUPAC nomenclature so that you guys will have that under your belt and then kind of help you understand the chemical names that we'll be working. Okay, so now we have to sit there because the double bond could be on the first carbon, it could be on the second carbon, it could be on the third carbon. So well, actually it could be on the first or the second carbon. If it's on the other ones, then we'd go to the smallest number. But because we want to sit there and specify where the double bond is located, we have to give a location. Since it starts at the first carbon, then we would call this guy, we'd add a number to this. So we'd call it 1 UT because it started on the first carbon. And we would call this one 1 butyne. Now this one, we didn't have to put any numbers on it because they're all single bonds, so there's nothing to specify. Okay. Let me know if you have any questions. Okay. So sometimes we'll be in situations where we'll have multiple double bonds or multiple triple bonds. Let me give you an example. Okay, so here we have 2 double bonds, right? one at the first carbon, one at the second carbon. One at the first carbon, one at the third carbon. So we need a way to sit there and let us know that we have two double bonds. So the way that we would do that, we would use another prefix. So for 2, there's 2, we'd use di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca. So these are the official Greek prefixes. If you take a look at the prefixes that we use for the carbons, you'll notice those first 4, they are different than the Greek prefixes. So you want to try to make sure that you don't get those mixed up. So we have 2. We have 2 double bonds. So when we go with the naming, we know that it's going to be a 5 carbon chain. So then we call this guy pentene. Now, since there's 2 of them, we want to let us know that there's 2 pentene. So then we would use pentadiene. Okay, di meaning 2, and we'd have to say where it's located. So it's located on the first carbon, and it's located on the third carbon. So we'd call it 1,3-pentadiene. Okay. So this would be one way of naming it. There's another way of naming it as well, where we put the numbers inside the name to let us know that it is. We usually use this when there are multiple structures or multiple, let's say a single bond and a double bond, so that we know where the single bond is at and we know where the double bond is at. I mean, not the single bond, but the triple bond and the double bond. So let me show you what that is going to So we can say penta dash 1, 3 dash diene. Okay. So does that make sense, Bernice? Okay. Sometimes, like I said, we'll have a case where we'll have a double bond and a triple bond. So when we talk about a double bond and a triple bond, we have to determine who's going to have priority. So the double bond has priority because it's more common than the triple bond. So if we look at everything, single bond has the lowest priority, triple bond has a second priority, and then the double bond has the highest priority. And when we go with doing nomenclature, it's based upon priority, right? Who's the most important, okay? So the double bond is more important, so it's gonna get the last name. So in this case, let's go ahead and number the carbons. Longest carbon chain, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now we want to try to set it up so that the double bond has the lowest number compared to the triple bond, because we could have started counting from this side, from the left-hand side, or we could have started counting from the right-hand side. We want to try to give everything the lowest number that we can give it. So in the case, the double bond has number 1, so it has the lowest number of 1, where the triple bond starts at the 6th carbon. So we would name this guy, and there's 2 ways of naming it. So the first would just let us know that we have a triple bond, and so we put where the triple bond starts, 6 dash YN dash, and then we have to say where the single bond is located at. I mean, the double bond is located at, and that would be 1 dash, and then it's an 8 carbon chain, so then it would be octane. Okay, so that would be one way of naming it. And you'll notice we use that YN and we drop that E, because that just lets us know that we have a double bond, a triple bond in that main carbon chain, and it's located at the 6th carbon. Now, this is one way of doing it. The other way of doing it is, again, putting it within the name itself. So we'd have octa, and then we'd put dash 6 dash YN dash 1 dash EN. Okay, so then this tells us that the triple bond is located on the 6th carbon and the double bond is located on the 1st carbon. And it is an 8 carbon chain. Okay. So the Y and E comes from the fact that we have a triple bond, okay, on the 6th carbon. Okay, because if you remember, when it's a triple bond, we would normally end it with YNE, but now since it's not the priority, it doesn't get the last name, so you don't put the E at the end of it. We say that for the E and E. Okay, so then we just shorten it to just YN. Okay, so then that lets us know that there's something that is more important in that carbon chain other than the triple bond. Does that make sense? That's a good question. Okay, so let's see if you guys can help me out here. So I'm going to put up one of the hydrocarbons, and then you guys can let me know if you guys can do the nomenclature. So we'll start simple. So this will be the first one, A. This is going to be B. That's C. Then this is D. Okay, and that's D. Okay, so I'll give you guys a few seconds to, a few minutes to put the names together, and then we'll go over together. Okay, so let's start off with the first one, A. So the first thing that we want to do is to do what? Okay, count the points. So we want to count the carbons. That's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. Okay, so then this guy would be called, has 6 carbons. So we'd use hex as our prefix. And since they're all single bonds, it would end with, yep, ane. That's right. That's correct. Okay, hexane. Okay, what about the B? First off, will we count from the left or will we count from the right? That's right. Start from the right. Okay, so then that's 1, that's 2, that's 3, 4, 5. And we start from the right because it would give the double bond the lowest number. If we started from the left, it would give the double bond a higher number. So we want to make sure it has the lowest number. Okay, so it's a 5 carbon chain. So then the prefix is going to be that's right, pent. So we'd put pent. Now, since it's a double bond, what is going to be the suffix? That's right, ENE. Okay, and the last thing that we have to do for this that's right. Well, it's 2 because it starts at the second carbon. So it'll be 2 dash. Okay, so we have to tell where the double bond starts at. Okay, so always remember it's where it starts at, not where it ends at. So it'll be 2 pentene. Okay. Okay, what about C? So are we going to start counting from the left or are we going to start counting from the right? Actually, let's do both so we can see the difference. So we'll do blue starting from the left. That's 1, 2, 3, 4, 5, 6, 7. Brown, starting from the right. So that's 1, 2, 3. That's 4. That's 5. That's 6. That's 7. That's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Count it that one twice. 4. Okay. So what is going to give us the lowest numbers? The brown numbers or the blue numbers? Okay, so the brown, so that would be 1, that would be 3, and that would be 6. Where the blue would have given us 1, 4, and 6. So we'd use the brown numbers. So we said there are double bonds at the 1, the 3, and the 6 carbon. Okay, the longest carbon chain is how many carbons long? Longest carbon chain is 7 carbons long. So it's hept, that's right. So we'd say hept. And we put that A in there because there's going to be a little bit more behind it. Okay, so there's 3 double bonds. So what prefix would I use to represent that 3? That's right, tri. So we put hepta, tri, and then it's a double bond, so it'd be E, N, E. Okay, so that would be one way of writing it. The other way of writing it would be putting the numbers in between. So then it'd be hepta 1, 3, 6 dash tri. Okay. Okay, and then D. So where are we going to start? So where we start counting from? So let's use the brown letters again. 1, brown numbers 2, 3, 4, 5, 6, 7, 8. Okay, and then blue numbers. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, which one is going to give us the lowest numbers? Okay. Okay, so are you sure? Because this starts on the second carbon, this would start on that first carbon. So the brown would give us the lowest number. Not only that, when we talk about priority, you always want to try to give the double bond the lowest number that you can give it. So you want to make sure it gets the lowest number first because it's more important. Okay. Do you understand that? So go ahead and start naming it. Let's see, brown numbers. So we have a triple bond and we have two double bonds. So what would be, let's do the base first. So what would be the prefix of the longest carbon chain? Octa. Okay, so we're going to use octa. Okay, we know that we have a triple bond, and the triple bond isn't priority, so we're going to list that one first. So the triple bond is located, if we're using the brown numbers, it would be on the sixth carbon. So to put 6, and then what would be that we'd use in this case? It would be another prefix because it's not ending. What would be the prefix that we use for a triple bond? No, not try. Not pro. So it also, remember, it's kind of like a suffix too, but we kind of use it only when there's triple bonds. Yes. So it's not the YNE, but it's just the YN. That's all right. You know, so it's just Y. Okay. Because remember, we dropped the E, so then we make it a prefix. Okay. So then we have two double bonds. So where are those double bonds located at? That's right, 1 and 3. So we go 1, 3, dash, and then since there's two double bonds, two sets of double bonds, what prefix would we use to represent 2? That's right, di. E-N-E. Okay? So this is one way of naming it. The other way of naming it would be 6 YN dash 1 3 dash octa diene. So either way would be okay to name it. Okay. Okay, so now let's go back to the slides. Since you guys, how are you feeling about it so far? Okay, just maybe need a little more practice. So. Okay, we'll get you guys there. Okay, so we're gonna go to the slides. Switch up. Okay. So Okay, so we've talked about saturated hydrocarbons and unsaturated hydrocarbons. We've also talked about how to name. So we also have what we call isomers. So sometimes we have carbons that have the same number of carbons, the same chemical formula, but where they're located is different, or the structure of them is different. So like for instance, this guy is called N-butene. 1, 2, 3. So this will be considered a common name by calling it N-butene. N basically means that these chains are located right next to each other, right? They're in a straight line. This guy is called isobutene. Iso meaning that you have a methyl group. This C is called a methyl, the CH here, and then the CH here, that's a methyl group. So you have methyl groups that are cationic to each other. That makes it an iso. It also has 4 carbons, right? And its chemical formula, if we just wrote just C and H, would be exactly the same. But structurally, they're different. You can see the difference between the two. So here's another example. So this here is N-pentene. N-pentane. This is isopentane, and this is neopentane. N-pentane, they're all in the straight line. Isopentane, again, we have a methyl group here, but a total of 5 carbons. And then this guy would be neopentane. So, and they all have 5 carbons, and they have the same number of hydrogens. So chemically, they're exactly the same. I mean, the chemical formulas are exactly the same, but structurally, they're different. Okay, and because they have different structures, their chemical properties are going to be different. They're going to behave different. Okay. So when we talk about that bonding, we know that these are going to be covalent bonds. They're also going to be forming, they're going to have a certain molecular geometry associated with it. So when we have carbon, if it's all single bonds, then we're going to have tetrahedral. If we have 1 double bond, then we're going to have trigonal planar. If we have 2 double bonds, then we're going to have linear structures. And then if we have a triple bond, it's also going to be linear. Okay. And we know that hydrogen only has 1 arm, so it's always going to be that single bond. The halides are always going to form single bonds. Oxygen, well, oxygen could have single bonds on both sides, so then that structure is going to be bent, or it could be a double bond, right? So in that case, it can be, well, depending on who it's with, it could end up being trigonal planar, or it could be some other form. Okay, so nitrogen is able to sit there and attach to 3 other things, and it's going to have a lone pair on top. So this guy's going to be trigonal pyramidal. If we have a double bond on the nitrogen and a lone pair on top, and then a single bond on the other side, so this guy is going to be angular. And then if nitrogen forms a triple bond, then it's going to be linear. So earlier we were sitting there talking about the tetrahedral modules. So when we're talking about the number of electron pair, or it's electron pair geometry, all of these guys are considered tetrahedral. That means that we're counting the electron pairs. So in this case, we're counting the electron pairs and the atoms that it's attached to. So this guy has 4 things that it's attached to. It has 4 hydrogens. So that's 1, 2, 3, 4. So it has 4 things attached. So 4 tetra, so tetrahedral. This guy has 3 hydrogens that it's attached to, and then it has a lone pair. So we're counting that lone pair as well. So now that would give us 4 attachments total. So its electron pair geometry is going to be tetrahedral. And then water has 2 lone pairs and 2 hydrogens. So again, 4 things that are attached. So this guy would also be tetrahedral. Okay. Now, its molecular geometry is what we actually visualize. So we don't really see those lone pairs, right? So what we do see is the atoms that it's attached to. So in the case of this has 4 atoms that were attached to it. So this guy is going to be tetrahedral. Now, we don't see the lone pairs, but we see the 3 hydrogens at the bottom. So it looks like a pyramid structure. So that's how we get the trigonal pyramidal. And then in the case of water, we don't see the two lone pairs that are on the oxygen. All we see are the two hydrogens. So it kind of looks like, Mickey Mouse ears, or we call it bent rectangular. So Brittany, I'll talk to you about the practice test. So it's not showing up yet?
No, only the exam.
No. Okay, so what I'll do, I'll check to see why it isn't showing up, and then I'll get back to you on that.
Okay.
Okay. So this is an example of the very top part is the ball and stick model. And this is just showing you the alkenes and the alkynes, right? So you guys kind of get an idea of what it looks like in terms of ball and stick model, and then also in terms of structure. Now, these are the two common names for the alkenes and the alkynes. So we've already talked about if there's only one carbon, then it's called methane, and then meth is the prefix, 2 F, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 none, 10 dec. So we've talked about what isomers are. So we can also have what we call, these are also isomers of each other. So here, if you look where the bromine is located at compared to the chlorine, these guys are considered to be isomers of each other, okay? They have the same chemical formula, but where they're located at is different. They're gonna behave differently because of that location, okay? We talked about you have to name the longest chain, carbon. Okay, so this is going to get us to the next part that I want to talk about when we go to the whiteboard. Okay, so for the whiteboard, okay, so let me erase the structures. Okay, so sometimes we have side chains. These are called substituents. Okay, so okay, so this guy, what's happening is that we have one carbon that sits off of the middle here, right? So the way that we would do it, we'd find the longest carbon chain that we can have. So that's 1, 2, 3. So that's 3 carbons, right? And then there would be one carbon that's hanging off of it. So since it's one carbon, we put meth, and then we put Y in at the end. So we call this guy, we'd have to say where it's located at, 2, meth, and then Y, not YN, YL at the end of it. And then it's a 3 carbon chain. So then we call this propane. Okay, so the side chain is only 1 carbon long, so then we call it meth. If the side chain was 2 carbon longs, then we call it eth. So let me give you an example. So here we want to find the longest carbon chain first. So let's go ahead and count. That's 1, that's 2, that's 3, that's 4, that's 5, 6, 7, 8, that's 9, that's 10. Excuse me. So then it's a 10 carbon chain. So then the base is going to be, what do you guys think the base is going to be? What is going to be the prefix for a 10 carbon chain? Deca. That's right. So it's going to be deca. And then, so it'll be decane. Okay, so we have the substituents on the second carbon. There's 2 meth. So then we put 2 dash dimeth. Oh. We have a, so, sorry. That's 1, 2 carbon on the 4th carbon chain. So then the prefix would be F. So it would be 4 dash ethyl. And then on the 5th carbon, we have 1, 2, 3, a 3 carbon chain. So then that would be propyl. So 5 dash propyl. So the name of this compound would be 4-ethyl 2,2-dimethyl 5-propyl decane. Okay, and so those substituents, since they're hydrocarbons and we want to know that they're just part of the side chain, we have to put that YL, okay, at the end of the prefix. Do you guys see that? Okay. So let's do something a little more harder. Okay. Okay. Okay, so we're going to start counting from. So the first thing that we want to do is to do what? Okay, we want to find the longest carbon chain. Okay, so, and we also want to try to make sure that our double bonds, since our double bonds have priority, we want to give them the lowest number. So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8. Okay, or we could have done it like this, where we had, again, 1, 2, 3, 4, 5, 6, 7, 8. Now, the rule of thumb is that we want to try to get as much stuff as we can into that main chain, rather than having a whole bunch of side branches. Okay, so if we can do that, okay, so then we'd want to try to incorporate this guy into our main chain. So we'd go with the purple numbers instead of the green numbers, because we had that triple bond that would be in that main chain. So let's go ahead and start off with the base part of it. So the longest chain is 8 carbons. So then the prefix is going to be octa. Okay, we have we have one triple bond that's located on the 6th carbon. So it'll be 6 YN. We have 2 double bonds located on that main chain. So, and they're located on the 2nd and the 4th carbon. And then in terms of the side chains, we have 2-methyl, we have an F on the 4th carbon, so 4-ethyl, and we have a propyl on the 5th carbon. Okay. So what I want you guys to do is, when you guys get a chance, look in the back of your shampoo bottle and look at the chemical's name on there. And you start seeing some of the nomenclature that we've been talking about on your shampoo bottles, and then on some of the stuff that you guys have around the house. Okay. How are you guys doing? Got a grasp on it? Okay. You don't got a grasp. Any questions? Okay. Okay. So the YL comes from the fact that it's a side chain or a substitute. So it's not on the main chain, it's coming off the side chain. It's like a branch, right? Like in a tree. So like the main chain is kind of like the stock of the tree, and then you have the branches that are coming off of it. So the side chains coming off of it, anytime that we have a side chain that's hydrocarbons, we have to use the YL. Does that make sense? Okay. So the other thing that I neglected to mention is that when we do the naming, we have to put those side chains in alphabetical order. So it's going to be based upon alphabetical order. Okay, so in this case, the E comes before the M. So then E goes first, then M, and then P. Now, we use the ethyl dimethyl. Well, di just lets us know that there's two methyls. So we use that methyl in terms of determining the order of it. We don't use that di to determine. Does that make sense? So your exam does not have problems like this, not on this exam, but the next exam that'll be coming up will. And what I'm planning to do is I'm trying to finish up your next exam and put it up early. So then you'll just be able to go to it whenever you get a chance to go to it. And then I will also put up your final. So then we'll have your next two exams and your final. That'll be up already. Okay. Yes, you should know how to draw the skeletal structure, and you should also know how to name. Yeah.
When is
okay, so you want to take the time to sit there and learn it. And if you guys have any problems, I'll kind of steer you to a site that helped me out when I was trying to figure it out. Well, I guess help me refresh things, right? And that was Melissa Maribel on YouTube. So just search Melissa Maribel YouTube, and then if you talk, say, organic chemistry, and so it'll actually show you how to go through the process of naming. Okay, so if you have any other questions.
Oh, when is it? Can you hear me? Hello? Oh, can you hear me?
So Melissa Maribel on YouTube. And I also have a link in my syllabus to her YouTube channel. So hello? I can't hear you, Brittany. Can you hear me? Okay, let me see why I can't hear you. Can you guys hear me, Brittany, on your side?
Hi.
Okay, I can't. Okay, give me 1 second. Let me see why I can't. Okay, try to say something now.
Can you hear me?
I can hear you now. Yeah.
Oh, my question is, when is the third exam gonna be? Like,
okay, so I will. So your third exam is going to be due the week. So the week after we get back from Thanksgiving.
oh, okay.
Okay, so you have time for that one. Okay.
Oh, okay. And also for the practice test for this exam.
It's not showing up.
No.
Okay, so I'll actually fix that. I'll see why it isn't showing up right after the lecture.
Oh, okay.
And I apologize for that. It's funny because I typically don't get it until I get like tons of emails on the weekends, typically about that. So I'll get that taken care of as soon as I can. Okay.
Oh,
okay.
so also I have another question. Sorry.
Yeah.
So are you giving us like more time in order to do the
exam?
Yeah.
Yes, I will be giving you more time since you guys didn't have a chance to do the practice exam.
Okay.
Okay, good questions. Don't know why my headphones aren't working. Okay. So let's go back to the lecture notes. Okay, so we've already talked about the longest chain, determining the longest chain when we're doing counting. So we talked about when there are two side structures, such as the methyls, and we have to tell you where they're located at. So because of the structure, we also have to be cognizant of the geometry. So when we're talking about naming, there's also aspects of stereochemistry. Now, stereochemistry is when we have the same chemical structure, and we have just minor changes, like in terms of location of certain things. I'll show you an example of that. So like say, for instance, if we have, see where it says X, Z, and Y, and right now we have the Z's right across from each other, the X right across from each other, Y is right across from each other, right? So stereochemistry would mean that we have, let's say, an X here, and let's say we have an X here, and then we'll have a Z here, right? So those would be, they would be stereo to each other, that location, that change in location. And they're going to behave different as a result of that, okay? So here is an example. They're not showing the unity of the hydrogens, but this guy would be called 3-bromo 2-fluoro. Now, when we have halides, what we do is, instead of saying chlorine, we drop the INE and we replace it with just an O. So it becomes bromo, right? Chlorine, instead of chlorine, it becomes chloro, okay? If it was fluorine, then it would be fluoro. If it was iodide, it would be ido, okay? Now, these guys, these halides are always going to be, they're going to be side chains, right? So they may be part of the main chain, but even then, they don't have priority. The ane would have priority, or the ene or the ine would have priority over these guys, okay? So they would always be, as I said, side chains or substitutes, okay? Do you guys understand that? So let me give you an example. Okay, so here I have a fluorine on the second carbon, and I have a fluorine on the third carbon. So we go about naming this guy. 1, 2, 3, 4, 5. So a 5-carbon chain is called penta. That's right, penta. And then it's all single bonds, so we put that A and E. Now, since there's 2 fluorines, there's one on the that's 1, 2, 3, 4, 5. So there's 2 fluorines, one on the second carbon and one on the third carbon. So we'd call that guy 2, 3. Since there's 2, di fluoro. Penta. Okay. Do you guys see that? Okay. And the other thing that you want to pay attention to is that B comes before C. So we want to make sure that we're putting things in alphabet. Okay. Paulina, thank you for emailing me on Friday about the things coming up. I need to fix that. For some reason when I just hit, because I opened up the next shells and then it put up those assignments before I want those to go up. So I'll fix that so you guys won't have to worry about those, and we'll kind of get you guys oriented. And then I'll send you guys an email to kind of list out the things that we're going to be taking care of for the next couple of weeks, since we're getting very close to the end. Okay. Oops. Okay. Sometimes we have what we call cyclo alkanes. Now, cyclo just basically means that the carbons are connected in a ring structure. Okay, so there's, in this case, this has six carbons in this ring structure. 1, 2, 3, 4, 5, 6. So then we would call this guy, since it has 6 carbons, the prefix would be what? You guys remember? 6. Prefix for 6 is hexa. That's right. So it'll be hexa, and they're all single bonds. So it'll be hexane, but we put cyclo in front of it. So it'll be called cyclohexane. Okay. So this is also a saturated hydrocarbon because it has all of the hydrogens so that everything is a single bond. Okay. So the nomenclature is going to be exactly the same. The only thing that we can kind of pick where we're going to start from. And usually you want to start where you have a substitute. So in this case, we'd start this one at 1, 2, 3. And we want to give it the lowest possible numbers that we can give it. So then we call this guy 1, 3, dimethyl cyclohexane. Okay. Now, we would normally start the numbers on the, again, we want to give the lowest possible number. That's the number one thing. Or it's going to be based upon priority. Okay? So if we had like a double bond off the top, we'd want to give that priority. Let's say we had a double bond here instead of that. So if this is a double bond, get rid of that hydrogen there. Okay, so it'll look something like this. Right. So we would want to give that one priority. So we started there. Otherwise, we could have started counting from here, 1, 2, 3, or we just said when it was a single bond. But when it's a double bond, we want to try to give that double bond the priority. Okay, does that make sense? Okay. Okay, so we've talked about the double bond already, so we can kind of skip that. We're already familiar. We've talked about the triple bond. So we've already talked about the unsaturated carbons. Now, the thing about single bonds, it allows for that rotation. So we have that free rotation that occurs. But since we have a double bond, we're limiting that rotation. It can't rotate. It's kind of stuck because you have those two bonds that are attached. And so single bonds are able to rotate around where the double bonds can't. They're kind of fixed. Okay. So this is called a benzene ring, right? Where you have, if you take a look at this, this is alternating double bonds within that ring structure. So they're alternating from one to one. So this guy would be called benzene. Okay. Now benzene is an aromatic carbon. It has smell. Aromatic means smell, has an aroma to it. So a lot of the things that we smell, like, strawberries or perfumes, a lot of them will have benzene as their base structure. And then we'd have different structures added on to give it different smells. Okay, so we have amphipathic open chains. So those are when your chains are open. We have amphipathic cyclic chains. So that's when we have those ring structures, but we don't have that benzene ring. When we have that benzene ring, it becomes aromatic. Okay. So the next thing I want to talk about are some of the other groups. So for instance, we have the hydroxyl group. So the hydroxyl group are part of the alcohols. So if we have an OH, so attached to that hydrocarbon, it becomes an alcohol. So the way that we would name this has two carbons, 1, 2, and then it has that OH group attached to it. So then we call this guy 2-carbon chain. What is the prefix for a 2-carbon chain? Okay, 2-carbon chain is eth, right? So it'd be eth. So we would call this guy ethanol. And the reason we use the AN is because it's all single bonds. There's no double bonds there. And we use the OL because it's the alcohol. Now, alcohol has priority over double bonds and triple bonds and single bonds. So the last name is going to be given the OL because it has priority. So if we think about priority, I'm going to give you a list of priority. At the very bottom, we have the halides, right? Or we call them the alkaline. Okay, that's at the very bottom. Then we had alkanes. And above that, we had alkyne. And then above that, we had alkene. Then we had alcohols. Okay. So again, the naming is going to be the same. The only thing that's going to be different is since the alcohol has priority, it's going to get the last name. So if we had, let's say, 1, 2. Okay, so if we had an OH coming off that side chain, right, we'd want to find the longest chain. So that's 1, 2, 3, 4, 5. Right, 5 is the longest chain. We'd want to start counting at the structure that has the more priority. So we start counting from this side. 1, 2, 3, 4, 5. So a 5-carbon chain. So what is the prefix for a 5-carbon chain? Penta. Okay, so we have penta. Okay, now we have a double bond on that first carbon. So then what we're going to do is put 1 AN. Okay, En. So that lets us know that on that first carbon, we have a double bond. And then on the second carbon, we have alcohol. So we put 2 OL. Okay. So this guy would be called penta 1-ene 2-ol. So that lets me know that double bond is on that first carbon. Second carbon, we have an OH group hanging off. And we notice that the OL is at the very end because it has the priority. So we get the last name of the one who was the most important. So the alcohol is more important. Okay, makes sense? Are there any questions? Okay, no questions. Okay. So the next thing that we're going to be talking about are ethers. Now, ethers, in terms of priority, they're actually low on the chain. They're down here. Okay. So, but there's 2 ways of doing ethers. There's one way which is called the common way, or common name way. And I'll show you how to do that just for these guys because it's a lot easier. And then I'll also show you the IUPAC way, or what we call the systematic way. Okay, so ethers are when you have oxygen between hydrocarbons. Okay. So the systematic way, or I'm sorry, the common name way would be just telling me the length or the length of each of the hydrocarbons on both sides of the oxygen. So in this case, we have so that's 1, 2. And then on this side, we have 1, 2, 3. Okay, so we have a 3-carbon chain over here, and we have a 2-carbon chain over here. So then we would call this guy, in its common name, it would be called ethyl propyl ether. Okay. Or its IUPAC name, you take the one who has the longest chain, and that gets to be the group. So then it would be so it'll be the smaller chain gets ethyl, then oxy. So oxy means that there's an oxygen, and then we'd call it propane. So it'd be called ethoxy propane. Okay. So the second way is the IUPAC system. Okay. And then the upper part is called common name. Okay. Questions? Which one seems easier to you guys? Okay, no comment? Okay, the IUPAC. Okay, so the key is, what I'd like you guys to do is, if you just think about the way that we've been doing nomenclature, it's going to be the same concept. Only thing, if there's an O between, then you know that you have to give that one the oxy, that shorter one the oxy, and then the one that has the longest chain gets the end. Okay, so it's not too much harder. The other thing is that I want you to be able to identify the different groups it belongs to. Okay, so you need to identify the alcohols. Does this belong to the alcohols? Does this belong to the ethers? And then also kind of pay attention to the priority. Okay. Okay. Okay, so this here just basically shows you the difference between the alcohol and what they're kind of similar to. So water, that's where we kind of get our hydroxy group. So it's very similar to water. And here's an alcohol. This is what an alcohol looks like. R represents that hydrocarbon. And then this is what the ether group looks like. It's that O, and then you have hydrocarbon attached. Now these R's can be exactly the same or they can be different, like I just showed you. Okay. So here, this is just showing you some of the nomenclature. That first name is the common name. The second name is the IUPAC. So for ethers, if the groups are exactly the same, we call it, in this case, diethyl ether. So we give it di, meaning two. Okay. And then we just put ether there. And again, this would be common. Otherwise, we'd call it, it'd be called ethoxy ethane. Okay, this is just showing you some of the alcohols. Again, the alkane portion, and then the hydroxyl group. This here is just showing you ether, and then the common name for that. Okay. Are you guys okay? You guys get that so far? And if you notice, kind of. Okay. So if you notice, this guy is a benzene ring, right? So if we have a benzene ring attached, instead of calling it benzyl, we call it phenyl. I don't know why it ended up getting that switch, but it does. Okay. Okay, so we've already talked about the process of naming. Okay, so the next groups that I want to talk about are called aldehydes. And I think I'm going to actually stop here and we'll pick this back up next Tuesday. So I will see you guys next Tuesday, and then I will actually, as I said, today I'll go through and fix those things, and I'll try to figure out what's wrong with your practice test and why it's not showing up. But does the test show up for you guys? You guys are able to see the second exam? Okay, but you just don't see the practice test. Okay, so I'll fix that. It showed up before the, okay. So I'll definitely fix that. So you guys will have some extra time. I'll give you guys a little extra time. And plus you guys, again, I'm kind of flexible with time and everything because like I said, this is the first time that I'm teaching where you're not required to attend my lectures. And so I'm trying to give you guys a little leeway on that. Okay. Okay, and if there's anything else, the best thing to do is rather than send me emails, because I get a lot of emails in a day and it takes me a while to get through all of them. If you could text me, like things like this, just shoot me a quick text message and then I can kind of squeeze it in when I can get it squeezed in, okay? And my phone number is actually located on my syllabus, or you can do it with Remind. Lately, my Remind app is working half the time, so do them both just in case. Okay. Okay. So I'm going to let you guys go, and then I will see you guys hopefully this Friday for lab. This Friday, what you guys are going to need for lab is actually it is a dry lab, and so what we'll be doing, we'll be going over nomenclature. So we'll be doing a lot more practice with nomenclature. I'd like you guys to show up because it sucks doing labs all by myself. It's kind of lonely. Okay, but it's not required. It's already should be posted, and so it should be kind of straightforward. Okay, so hopefully I get a chance to see you guys.